All right. Good morning again. Happy Monday. I hope you guys got some rest over the weekend and excited for this week. And we have one more week of online classes or synchronous classes, and then after that, we are going to meet on campus. All right. Now let me reconnect this. Anyone has any questions for me? If not, we are going to complete our chapter 1 today, and then we'll start our chapter 2. And as you notice on Launchpad, your homework assignments, date, and quiz is extended. As we discussed on Friday's class, that we did not get to cover uniform distribution. So today we will cover uniform distribution. And I noticed that some of you have already finished your work, so that is fine. But if you want to take the third attempt for your homework assignment today or tomorrow, feel free to do that. Why it is not connecting? So let me check that again. It's taking time today. It was connected before the class, but not connected. Okay, last time. So let me connect one more time. If it's not, I will use the whiteboard. Happy Monday. Not connecting. So let me sign out from Zoom and then sign in again. I don't know what issue it is. I can see my internet and everything is working well. No luck. Anybody has any idea or suggestions why it is not connecting, or what should I do? I'll do this now. Can you guys see that?
Yes.
Okay, perfect. Yes. Finally, happy Monday. All right. So, without wasting further time, it's already past 4 minutes. Let me talk about what we did in the last class and what was left from this chapter. So, we talk about density curve, and we also discuss what are density curve. We talk about normal density curve, and then we find the area under the curve using empirical rule, which is 68, 95, 99.7 rule. So we use this rule. And then we also use tables to find the area under the normal density curve when we are not looking for 68, 95, 99.7. We also looked at the area under the curve using mean as 0 and standard deviation as 1, which we call it standard normal density curve. And we also used, when we are not using standard normal density curve, with different mean and standard deviation to find the area under the curve with a specific range. And that range can be either negative, starting from negative infinity to some number, let's say 70, or 70 to positive infinity, or between 64 and 70. So we use different interval or different range. And we use table A to find the area under the curve. We also use calculator to find the area under the curve. So this is example on Stat 108 chapter notes. If you go there, you'll find that if we are looking at the 68% area or 68% observations in the curve, then we are looking at one standard deviation to the left and right of the mean. So this is my mean. When we talk about normal distribution, we use this. Mean as mu and standard deviation as sigma. So if my mean is 336, that means my center or half is on 336. Left of 336, 1, 2, or 3 standard deviation. Depending upon what my standard deviation is, I will keep on subtracting 336 minus 3, then minus 3, and then minus 3. Same thing here, I'll just keep on adding 3, 3, 3. And then I will find how much is 68%. It is between this, then 95% between this range, and same thing for 99.7%. By using this 68, 95, 99.7 rule, we can also find how much is the range, or how much is the area covered between these two, or any two. So we can look at any range knowing that how much is in each particular range. Since it's symmetric distribution, whatever I have on the left, I have the same on the right. This is 50%, this is also 50%. If this is 34%, this is 34%. 13.5, 13.5. If I find one, either on the left or the right, the other side or the other will be the same. Then we use an example using the table as well as using the calculator if I'm looking for the value of z less than 0.81. And remember, as we discussed in the last class, when we are looking at the area under the normal table, table A, it gives us the area to the left of the table. It gives the left of this density curve. Either you look at this or this, we always get the left-sided area using table A or standard normal table. If we can just get the left-sided area, how do we get the right-sided area? Or what do we need to do to get the right-sided area? We know that density curve has the area under the curve as one whole or 100%. If we can find the left-sided area, we can subtract it from 1 to get this right-sided area. This is when you use the table. But when you work with the calculator or software, you do not have to do that, because now you know left-sided area is how much, what is my range. So I'm looking up till here from here. And if I do not know my farther left, I know it is negative infinity. Same thing if I'm looking for the right-sided area after z, and I don't know what's my upper bound, I know the maximum I can have is positive infinity. So you can use your calculator to find the right-sided area as well as left-sided area, or the area between these two, whatever range you have. So if we are looking for the area under the curve for z less than 0.81, these are the calculator instructions that we used last time. And I see that most of you are doing your homework assignment. So you are using either the table or the calculator. Just remember, when you work with negative infinity, use the negative sign and then bunch of nines. And then this is your positive 0.81 and mean and standard deviation. Again, when we talk about normal distribution, we are using mean and standard deviation as 0 and 1. And if your mean and standard deviations are different than 0 and 1, then plug those mean and standard deviation. And then you can find that. So this is one thing that I want to review. And the other thing that we were doing the last topic in the slide that we were doing is, if the area is given to us, how do we find the corresponding z or the corresponding x value? So first of all, we know that if we are looking for z, this is the formula that we use for standardized score or z-score, where x is what you are looking for, mu is your mean, and sigma is your standard deviation. If you are looking for z, first thing, you know what your x is, mean and standard deviation is given, plug it and solve for z. You get that z value, go to your table and find the corresponding area. If area is given, how do you find z? So again, when you look at table A, so let's say first the area is given to as 10%. First of all, whenever your area is given to you in your percentage, convert into decimal. When you look at table A is in decimals and they are 4-digit after the decimals. So it is given to you. We were doing this problem in the last class. So let me just go over. According to the Health and Nutrition Examination Study of 1976 to 80, the height of adult men age 18 to 24 is normally distributed with mean 70 and standard deviation 2.8. And again, we are not talking about standard normal here, so we are not saying n0 and 1. If you are looking for, if they said 0 and 1, then you can use that. But here your mean and standard deviation is given as 70 and 2.8. If exactly 10% of the men age 18 to 24 are shorter than a particular man, how tall is he? So you are looking for the value of x. How tall is that man is? And we know the formula is x minus mu over sigma. So again, you can do it two ways, either using the table or using the calculator. If you are using the table, you're solving for this x. You know these two. This is given to you in the question. Mean is 20 and standard deviation is 2.8. But we don't know z. But we know how to calculate that z because the area is given to us as 10%. So what I will do, I will go to the table and find the closest value to this in your table A. So let me go back to table A, and last time we were using, so let me start again. So now we are looking for 0.100, this thing. And if we look at the table starts from, first let me clean this part. So we are looking for this value. And now look at the table. The table starts from here, 0.0003. And we need 0.1. So first keep on moving where you will get 0.1 or closer value. So again, 0.0, 0.0. So here, up till here, I see 0.096. And I'll keep on going. And when I keep on going here, this 0.1151 is way bigger, little closer, closer, keep on going. So I find these two values, and these two values are very closer to what I have. So my this value, and we have done this in the last class also, but just want to go over again so that it will make more sense. So when we look at this value is in between. And then we will see how close this value to my low, this and this. So whichever is close, we will take that. And if we look at this value is closer, and when we say this value is closer, we will find the corresponding z. So we will go to the left of that, which is negative 1.2. And then we will go on the top of that, and which is 0.08. So we'll get negative 1.2, 0.08. And you can write negative. And this is your corresponding z. So once you have z, go back to our original problem. Now we have z as negative 1.28. We have mu, we have sigma. Can we calculate x? Yes, just change this formula. So I multiplied this with z with sigma and move my mu on the other side. So that's how I can calculate my x. And again, I did not change anything. I just changed this formula, or not change, I just manipulate the formula a little bit so that I have x on one side and rest of the thing that I know to calculate x on the other side. These two things are given. This I calculated. I plug everything and I can find the area. I can find my x value. And this is how they explain it here. That's what we just did in the table. So you get this value, plug here, and then you get this value. And again, when we are doing statistics, just writing this value is not enough. Explain in word what is this 66.42 means. So again, we are talking about inferences or explaining in the word. You know statistic, I know statistic, but if we are explaining it to somebody, what is this 66.42 means when that person does not know statistics? So go back to your question and see what is given to you in the question and write that. A man would have to be approximately this much inches tall or less to be in lower 10% of all men in the population. And this thing comes from your question here. So you are just using that information that is provided to you in the question. So this is how we use table. How do we use calculator to work on these kind of problems? Last time we talked about when we are looking for the area of z less than 0.5, we use normal CDF because we are looking for the cumulative distribution, how much is from negative infinity up till 0.85. Now the area is given to us and your mean and standard deviation is given to us. And if you are looking for the corresponding value, use the third option, which is inverse normal. And when you do inverse normal, it asks you area, mean, and standard deviation. And again, the area is given to you as 10%. And your mean is given to you as, I guess, 70 and 2.8. And then you will find the corresponding x value when you plug this. And again, area is given. When you are using the calculator, write a note to yourself. When you write the area, you do area to the left. And when you use the table, if you are looking for the right-sided area, you subtract that value from 1. But when you're using the calculator, you're not doing. So plug area to the left side. Even if right-sided area is given, let's say this area is given to me as 20%, and same thing, mean as 70 and standard deviation is 2.8. When I'm using this calculator, first I convert this into decimal. Again, table does not give me the right-sided area, so I will find how much is the remaining left-sided area, which is 80%, so 0.8000. So you use this information, and then your area is 0.8000. Mean is 70, and standard deviation is 2.8, and then you can calculate. If you are looking for z, only the value of z, what is my value of z when I'm using this information? So if you're looking for the value of z, you know that when we are looking for the value of z, we are using standard normal. We are using mean as 0 and standard deviation as 1. So if you're solving for z, you do the same area, then mean 0 and standard deviation 1, and you get the corresponding z value. Questions? If not, let me quickly talk about the last topic, uniform distribution. And I am using the chapter notes for Stat 108. They are on your Canvas, so you can find that information there. So far, we talk about normal density curve. Now, what is uniform density curve? So when we are saying uniform density curve, we are using a curve, or we are making a density curve that is uniform at all the points. So let's say this is, I'm making a density curve starting with 0, 1, 2, 3, 4. Then I observe 0, this point. At 1, I observe this. 2, observe this point. I don't know what that, but this is given to me. So when I make this density curve, this is uniform at all the points and it is taking a shape of a rectangle. So when it is taking a shape of a rectangle, we are talking about a rectangular shape curve, and that is called your uniform density curve. And the definition is also given here. Uniform density curve is a rectangular shape so that the proportion of the area can be found the same way how we find the area of the rectangle. And how do we find the area of the rectangle? Is length times its width, right? And sometimes we say length times its breadth. So when we are looking for area under the curve or area under rectangular curve, first of all, we know how to find the area of a rectangle. This is the formula we use. And we have one more information. Since we are talking about density curve, we know that the area under the density curve is 1 whole. So we know that area in the density curve, when it is uniform, we use the formula length times width, and the area is 1. We know if we are looking at this particular example, how much is the length of this?
4.
4. How we are doing? We are looking for what my maximum is, what my minimum is, and then I can say the length is 4. The length is 4. I don't know what the width of this is, but I know that the area under the curve is 1 whole. So by using this information, can I find the width of this rectangle?
Yes. Yes.
Yes, and that will be 1 over 4. Or you can think of that, it is the reciprocal of your length. It is 4 and width is 1/4. And we can check using this length and width. When my length is 4, width is 1/4. Is my area 1? And I can check area of the rectangle is length times width, which is 4 times 1/4, and which is 1. So that means length times width can only be 1 when 1 is the reciprocal or the inverse of other. So once we know the length, we can find the width. But if I need to look for area of only this part, can I find that using the information that I have? Let's
Yes.
see. Yes, so let's see. So if I'm looking for the area only for this specific part, that means what is my length in this case?
1.
1. And how? You can think of that as A and B, and which is 4 minus 3, 1. So my length is 1. What do you think the width? Will that be 1?
1/4.
1/4. So your width is not going to change. You are looking for the area of this one, right? This particular. So I'm not talking about this whole. I'm just looking. So my length is less. So I'm looking for this. My width is still 1/4. So when you are looking for the area of this particular part, we know that area is 1 times 1/4. So this is 1/4 or 0.25. Similarly, can we find the area of this part?
Yes.
And without solving anything, can we tell how much is that?
Yes.
Yes. So if I'm looking at this particular example, I know that I'm dividing into 4 equal parts, 0 to 1, 1 to 2, 2 to 3, 3 to 4. And if it's 1 is 1/4, each of them is 1/4 to make the area under the curve as 1 whole, right? So when I'm dividing into 4 equal parts, it's easy for me to calculate. I can say the area of this is 1/4. And if I'm looking for the area of this one, it's 1/2. Or if I'm looking for this one, let's say, if I'm looking for this one from here to here, I can say 3/4. So I can find that. Not a big deal. But if I have something like this, and I need to look for the area between 2.2 and 4. Can I find that?
Yes.
Yes. Is it hard?
No.
No, but it is a little bit more work. It's the same logic that we did. We use what? We use this. Let me just do this. Let's say I have A and B, and this is my density curve. So this width will be, if this is B minus A, that's what I'm doing, right? To find the length. So this will be 1B minus A. And when I multiply B minus A times 1B minus A, that will give me the area. So again, that B and A can be anything. As long as I know my width, I can find my length depending upon what I'm looking for. So let's use this information. So we are talking about this and this and this whole thing, let's say. First of all, we need to know how much is this part, right? To see if the area under the curve is one whole. And we just work on this problem. It's 4. So this will be 1/4. Any question up till this point? Where did we get this 1/4 from? Okay, once we get this, now I need to find how much is this or this. And again, as I said, B minus A. So look for that. 4 minus 2.2, and which will be your 1.8, right? And when you are looking for the area is length times width. You calculate your length as 1.8 for this particular region. I'm not talking as a whole. And then width is 1/4. And then you can solve and you can get that area above 2.2 or between 2.2 to 1.4. Questions? Similarly, if I'm looking for 0.7, if I'm looking for how much is the area less than 0.7 and greater than 2.2. Now the problem looks a little bit more or you can say that little bit different. But if you look at this problem is asking you the same thing, but just a little bit more work. Less than 0.7, that means I need to look for this area. And greater than 2.2 is this. So I will find this area in this area and add everything. I will find that answer. This is one way to do that. The second way is if you are looking for this and this, why I'm doing double the work? I'm solving for this, I'm solving for this. When I can find the area for this one and subtract from 1, and I can find how much is the remaining area. So it is totally up to you how you want to do. You can find this area, you can find this area, add, you get the answer. Or you can just find this unshaded area. If you know how much is this, you know that the area under this whole curve is one whole. And if I subtract this from 1, I can find the remaining. So that is your uniform distribution. Questions? So that ends our chapter. And I think there are examples here also. So let's do one example from here for uniform distribution. Here. So here says examining the location of accident on a level 3-mile bike path shows that they occur uniformly along the length of the path. The figure displays the density curve that describes the distribution of the accident. Again, it starts from 0 to 1, 1 to 2, 2 to 3. Again, we know how much is the length, which is 3. And the width is 1/3, or the height or the breadth is 1/3. And when you multiply 3 and 1/3, it will give you one whole, this. And now verify that this figure is a density curve. How do you verify? Let's see that it is on and above the horizontal axis, which it is. And the area under the curve is one whole. And when you look at this one whole, you see that this is a verify, oh, this is a valid density curve. Now, what proportion of accidents happen between 0.7 and 2.5 mile walk? So we did very similar example. We did 2.2 instead of 2.5. So it's done the same way. You look for this area, subtract from 1, or you look for these two and add. And it is given base and height 2.5, 2.7. And once you get this, you can find the area. It's saying that between, and we were looking anything other than that, or we were looking this area, but this example, we are looking for this one. So in case, first you solve this part, and the second part is saying that find the area outside 0.7 and or less than 0.7 and greater than 2.5. Then what do we do? If we have already solved this, then just subtract from 1. You don't have to go again and solve these separately. Since you know how much is this is 60% of your area, and I know that the total is 100%, then this is my remaining 40%. And there are more examples. So take a look at that and let me know if you have any questions. So let's start chapter 2. And as I mentioned in the beginning of the class, your due dates for chapter 1 as well as chapter 2 are moved because we did not get to cover everything last week. So I really do not want you to rush and work on the concept without learning those concepts. So I think chapter quiz is due on 3rd, as well as your last homework 1.4 is also due on 3rd. So today is 1st. You still have 2 days. And we will have class on Thursday. I have office hours. And Miss Minion is also working for Math Help Center tutor and the schedule is uploaded on Canvas as well. Mr. Ryan, I guess. Mr. Philip is also doing math tutoring hours for our class. So if you have any questions, please look at their schedule and use their office hours or Math Help Center hours because they are assigned specially to help you guys if you have any questions. Again, when I say question, that does not mean your homework and quiz is question before you attempt. So once you work on those and still you have concept or that is not clear or why my question is wrong, what am I not doing correct, what I'm not getting it, feel free to ask them. And Miss Minion is helping us in this course as well. So you all know her well. You can look at her office hours, her Math Help Center hours, or Mr. Philip, or my office hours, and take good advantage of those. So chapter 2, we have 17 minutes, so let me just start. So chapter 2 saying looking at the data relationship. In chapter 1, we talk about data. What is data? How do we look at the data? Is it numerical or is it categorical? If it's numerical, how do I graph it? If it's categorical, how do I graph it? Once I graph it, how do I read it? What is the shape of that distribution? What is, if the shape is symmetric, what should I take as the center? So we talk about these 4 things: shape, center, spread, and if there are outliers in your data set. So we look at these 4 things and then we work on it. Now we are going to talk about the relationship between 2 variables. And when we are saying 2 variables, we are talking about bivariate data set. So when we are saying bivariate, that means each individual has 2 variables. So when we are saying individuals, again, we learned that in chapter 1, what are individuals are object of interest, and then the characteristics of those interests, object of interest are your variables. So when we are looking for 2 characteristics, or when we are looking for 2 variables, we have 2 variables for each individual, we are working with bivariate data set. And if you see the word bivariate, bi means 2, variate, we are talking about variables. So we are talking about 2 variables. And when we work with bivariate data set, we use scatter plot to see if there is a relationship between those variables. Or you can say that scatter plot is the first way to work with the bivariate data set to see what kind of variables we are working with. So when we when we look at the relationship, first thing we make a scatter plot. And what are scatter plots? Again, as I said, the word makes sense. So we are making a plot in which the points are scattered around. So if let's say this is my x and y, so I have a plot where the points are scattered around, and I need to read those points or on this scatter plot to see if there is a relationship between these variables or not. So when we are talking about scatter plot, as you see, I make a plot using x and y. So I need two variables, x and y, to work with or to find the relationship. And if you see in general, can we find a relationship when we have only one variable? To find the relationship, we need at least two, like if there is a relationship going on or not. So we cannot just see the relationship with one variable. So we are working with two variables, and out of those two variables, one variable is called your explanatory variable, and the second one is called your response variable. So again, explanatory variable, that means that explains the change or cause in other variable, is called your explanatory variable. And when there is a change that you can see, it is called your response variable. Or you can say that when you get a response using an explanatory variable, we are talking about response variable. So we are looking for two variables. One is your explanatory variable, another is response variable. One explains the change or cause in the other variable, and the other one will respond depending upon what the other variable is. So this we are going to learn, and then we will talk about correlation. What is correlation? Again, there is some type of relation, and that is correlation. And what kind of that relation is, we will talk when we will discuss what a scatter plot is, how to read that scatter plot, and then we will come to this correlation. Once we know if there is a correlation going on, then we draw least square regression lines in it. And next, we are going to see, when we talk about correlation and regression, what are the things that we need to keep in mind when we work with correlation and regression, how they are similar, how they are different. Then we will also talk about two-way tables, when to use two-way tables, and when to use your correlation and regression. We cannot use two-way tables and scatter plot, or you can say correlation and regression at the same time. So what kind of variables we use correlation, regression, what kind of variables we have when we work to what kind of variables we use two-way tables. And then we will also discuss causation. What is causation? What are the things we need to be careful when we say that there is causation or not? So relationship, again, what is an association between variables, explanatory response variable, and key characteristic of data set? So first thing, we are using the word association. What is association means? When we say two variables are associated, that means there is any kind of relationship going on between two variables. So two variables are associated or related. Association means any relation. When there is a relationship between two variables, we say that there is an association. Explanatory response, we just talk. So let's see their definitions. Many interesting examples of the use of statistic involve relationship between pair of variables. Two variables, again, measured on the same cases. So when we are saying two variables, they should be coming from the same individual. In cases, we use the word this. This is same as individuals. So two variables measured on the same individuals are associated if knowing the value of one of the variables tell you something that you would not otherwise know about the value of the other variable. So if there is a relation, that means knowing one will help us to know about the second variable, then we are saying they are associated. When you examine the relationship between two variables, again, a new question comes and is your purpose simply to explore the nature of the relationship? Or do you wish to show that one of the variable can explain variation in the other? If we are looking if there is an association going on, or if we are looking if one is explaining or causing the change in my other, then we need to study which one is my explanatory variable, which one is my response variable. A response variable measures an outcome of a study. An explanatory variable explains or causes changes in the response variable. So you need to identify which one is your explanatory variable and which one is your response variable. If the variable is causing a change in the other variable, then that variable is your explanatory variable. So let's say take an example of height and weight, or age and height. When your age increases, how does height increases up till the age of 15 or 20? So we are talking about two variables. If one is increasing, what happened to my other one? Is it increasing, decreasing, staying the same? So if one is giving or one is bringing the change or cause in another one, then that is your explanatory and the other one is your response variable. So we talk about these in the last chapter, and this is we are adding explanatory and response to our vocabulary that we learned from chapter 1. So cases, individuals, label, when we need to identify or when we need to identify your cases using different labels, like A students, freshman students. Let's say my individuals are UNCG students, and I'm labeling them as freshman, junior, senior, sophomore. So I'm labeling them. And then categorical, quantitative variables, we know how to identify those. And then identify the possible value for each variable. And this is, we are adding explanatory or response variable. If appropriate, classify each variable as explanatory or response. So first try to find out, is this explanatory or response? So this is the fifth part that we are using or we are learning in chapter 2. Scatterplot, interpreting scatterplot, and can we make categorical or can we make scatterplot using categorical as well as numerical variable? If we can, which one will make more sense? Which one is helpful to understand numerical data? Which one is helpful to understand categorical data? We are going to talk about that. So scatterplot, again, a plot where we have a lot of points that are scattered around, and we use those points to see the relationship between two variables. The most useful graph for displaying the relationship between two quantitative variables, and make sure you highlight this part, when we are looking at the relationship between two quantitative variables, our first thing is to make a scatter plot. And again, we will talk when we are talking about two categorical variables, how good a scatter plot is, and if we cannot make scatter plot, what can we make, or how should we find the relationship between two categorical variables. So scatter plot shows the relationship between two quantitative, and you can write as numerical, because we work with numbers, right? Numerical variable measured on the same individual. The value of one variable appear on the horizontal axis and the other variable appear on the vertical axis. So when we are talking about two variables, one is on x and one is on y on a scatter plot. Each case corresponds to one point on a graph. Let's say this is the point here, or this is the point, this is the point. Can we make this point just knowing the value of x? Let's say my x is 2. Can I make this point with just knowing the value of x? And the answer is no. I need to know what my x is and what my y is. So each point corresponds to x and y. So when we are saying x and y, I need to know what my x is, what my y is to make this point, or this, or this. So each case, And again, these are coming, this is one individual x and y, this is another individual value of x and y, x and y. So each case corresponds to 1 point on the graph. How to make a scatter plot? Again, if you have a larger data set, we will not suggest you to make a scatter plot by hand. You can use calculator, you can use any software, but the thing that you need to know is which variable should go on each axis. If the distinction exists, that means if you can figure it out which one is your explanatory variable and which one is your response variable, then plot your explanatory variable on x-axis and the response variable on y-axis, if the distinction exists. And if not, then if you do not know which one is my explanatory and which one is response, sometimes it happens we don't know which one is x, which one is y. If I'm looking at the height and weight, I don't know if I'm predicting the height or if I'm looking at the relationship between height and weight. And if I know if I'm predicting which is our next topic, then we know which one is my x and which one is my y. But when initially step I'm working with, when I'm looking for how to make a scatter plot, if I know what is my explanatory and what is my response, then make sure do your explanatory or plot your explanatory on x and plot your response on y. And if you don't know, then you can plot anything on any axis. Label and scale your axis and plot individual data values. Again, depending upon if I have only 5, 10, 15 data points I can do, but if I have 10,000, I'm not going to do it manually. I will use some kind of software to do that. So make a scatter plot of the relationship between price and rating for laundry detergent. So here is the scatter plot. So you look at this as if you do price as x and laundry detergent as y, so 14 and then 60, and then you keep on plotting. And as mentioned earlier, again, use some kind of statistical software or use your calculator to make a scatter plot if you have larger data set. But again, if you have 5, 10 observations, it's easy to make a scatter plot. And that scatter plot help us to see if there is a relationship between two variables going on or not. And how to see that or how to interpret your scatter plot. In last chapter, we talk about how to look at the overall pattern of a stem plot or histogram. Here we are talking about how to look at or how to read a scatter plot. So last time we used shape, center, spread, and outlier. When we are talking about scatter plot, we are looking for form, direction, strength, and outlier. So I'm just connecting it with the previous chapter. There also we were looking for 4 things to read the overall pattern of a stem plot or a histogram. Now we are looking at the scatter plot. I'm looking at form. What is the form of that scatter plot? Then I will look at the direction. What kind of direction I have, upward, downward, positive, negative, and then what is the strength or how strongly or how close the data set are towards each other. Is there a weak relationship? Is there a moderately weak? If there's a strong, then this strength will tell me. And again, the last one, we are going to look at the outlier, which is, again, anything that lies outside an overall pattern is your outlier. All right, so how to interpret your scatter plot? First part, we are going to look for these 4 things. As in any graph of the data, look at the overall pattern and for striking deviation from that pattern. You can describe the overall pattern of a scatter plot by using the form, direction, strength, and outlier. So when we say form, the form can be either linear or non-linear. And remember, we talk about symmetric, non-symmetric shape. Now we are talking about form. What kind of form we are getting when we look at this scatter plot? Is it linear? And again, when we are saying linear, that means is it making a form of a line or not? And if it's not making a form of a line, is it making something that is not in the line form? That can be curve, that can be anything that is other than your line. So if it is not making a shape, or if it is not making a form of a line, we call it non-linear. So linear, again, the form of a line. Anything other than line is non-linear. Direction, either positive or negative. So that means if it is making a shape of a line, is it going in the upward direction or is it going in the downward direction? And strength, if I'm looking at the scatter plot and I can see a form of a line, how closely those points are close to that line and how closely they are making the form of a linear pattern. If they are too close, we say strong. If they are far, we say weak. And again, outlier is an outside of the overall pattern. And I guess we are past time, so I'll stop here and we will pick up from here in our next class. Happy Monday and have a good rest of the day. I'll see you guys on Wednesday. Have a wonderful day.
Thank you.
Sure, I have a quick question. Can you hear me?
Oh, yes.
I have a quick question.
Yes. Did you take another class from me?
No, I don't think
No.
so. I think it's my
Okay.
first class for you.
Okay. Okay. Sorry. You look very familiar, so I thought you
I must have that kind of face. So the homework I see on the Launchpad says due for the 1.4 in the quiz is due February 2nd, which is tomorrow.
Second.
and the 3rd.
Okay. I thought I changed it to third, but I'll do it to third because I want you guys to have enough time to work on that.
Okay, gotcha. Okay, just curious. All right, thank you.
No, thank you for telling me. I thought I did change, but maybe I did it for other codes.
Gotcha,
But I'll
yeah,
do that.
sure.
Yeah, I'll do that.
Have a good day.
Thank you. You too.